Hello. So to start off, in the previous video, I had some problems with the sound where I was hearing myself speak. I hope it doesn't happen again, but let's see. So let's just I'll just start smoothly, and I want to show you something. So this is Git Kraken. It's a software for Git, for version controlling. Again, this is not sponsored. This is just me doing dumb videos. And because I recently used this program because it came out like this year, I want to shout it out because it's a really good program, and for Linux it's one of the few that has a good design. It's easy to use. It has an undo button, and you can see here it's my commits, my pushes, my program. Let's just say that it's, although it has like 20 or so, I don't know, 20 or so commits. It doesn't look like much, but it already has a lot of things. So I've always told myself as a programmer, as an informatics guy, that I only commit when it's functional, when it's working. Therefore, these whole changes in the last commit, it shouldn't be done like this. So you should always write. This one is smaller, for example. So as you can see, when I decide, okay, here I'm going to do this, I have a checklist on my side, or mostly written on paper, and when I say, okay, I'll implement the emotional replies, or I'll change the pointers, it's a thing that it's not very small, so I have to do a lot of changes. And most of the times when I have to change or to add stuff, for example, the world manager, whoa, this was a long time ago. It involves changing more than one file, because I don't just put it there, I put it there and add stuff to other files so that I can use it. So the big point is, yeah, you should always use a version control, and try to always describe your commits, and when you do a big one, you have to explain what you did. Okay, that this is a lot of changes for such a small explanation, but if you open a file, you see that most of the times I changed, okay, here I changed pointers to shared pointers, for example, or smart pointers to be more general. Here, yet again, I changed the pointer to a smart pointer. Include memory, of course, because it is needed to have a smart pointer. So let me just present for people. Okay, so let me just do a thing. Okay. No. Give me just a second. So another thing I wanted to say is that the program I'm using, it's connected to my GitHub account. So there I have a lot of projects I've developed. since my early days in college. I think I was lucky enough to save them and to put them on GitHub later, even though I didn't always use version controls. Okay, the thing is, I'm sorry, I'm really distracted. I have some other tabs open, and okay. So the thing is, I'm doing this. I could always just um, I could always just trim this later, but I want this to just be pure, just raw footage. And since I'm not a YouTuber, I'm just doing this so I can focus more. I can be more focused while I work. I think this is good for me. But yeah, I really don't know what to expect from these videos. And if I say something stupid, then I'm sorry. Okay, so I think I'll get going because I have to start this sometime. And I'll start off by showing you my GitHub other than the Git Kraken itself. So let me just share my screen with you. Okay, here you go. So this is my page. How do I see the other repositories? Since I don't come here often, I'll get a little bit lost. Okay, your profile. So, what do I want to say about this? It's quite simple. GitHub, and for those who use Git, this explanation is more for the people who don't really know what Git is or a version control system is, but also for new developers that are starting to use this. Essentially, Git is a repository for your code. And what this means is that if something goes wrong, if you delete your project, if you just lost some data, you can always retrieve it from the server where Git is storing your code. And also a lot of other cool stuff. If you are working with some colleagues and you're editing the same files on different computers and you commit your files, the good thing here is that Git will try to merge them, and only if there is a problem, if, for example, you're both working on the same function and it ends up being quite different from one another, it will generate a conflict and you have to resolve it manually. But other than that, many times you work on separate files, on separate regions of the same file, and Git tries and succeeds to merge them. But what I also want to say is that when you're using things like GitHub, like Bitbucket, I don't have an account there, but I know it's quite good for what I hear. And there are other Git servers and other version control servers also. I prefer Git, but for example, for large files, it's better to use other version control systems. But especially for people who don't have a lot of a profile of a curriculum, you can always expose your projects here. So you can have a private project or a public project. Normally, the private projects are paid, but if you're a student, you can ask for GitHub Students package, and yeah, student developer package. And you'll get a lot of things. So Atom it's free, but for example, GitHub, you get unlimited private repositories, which are normally paid. You'll get Microsoft Azure, although I prefer Linux, of course, but this is quite good because you'll get some really good tools. Although I prefer Linux, as I said, Microsoft has a lot of good software, and you should use it if you're willing to, or if you prefer. Again, you can have a domain where you normally pay. It's free. You have a lot of things, but oh yeah, Unreal Engine also, but Unreal Engine it's now free, so yeah, it doesn't apply anymore. And again, you can show your project, you can show what you do if you're a programmer, and you can do it here. For example, I made a video game with some colleagues of mine some weeks ago. We made it in 3 days for a competition, and yeah, we put it here, and anyone who wants to see the code, who wants to use it, of course, I think I made a license. It's an MIT license, so again, you can modify it. But you can't blame us and stuff like that. So for your protection, you should use a license. But if you don't know, or you don't feel like using a license, yeah, just ignore it. Just do your code and let your colleagues and everyone know what you do. And I think it's a good way to start. So after this boring introduction, let's get started. Again, this is my stuff, and I'll stop sharing like this and just open up the big programs. Okay, I think I'll start sharing because I'll be switching just share the screen normally. The other way we can share is by selecting one specific window. That's what you've been seeing. But I think I'll just share normally. Yeah, share desktop. Yeah. Whoa, infinite shares. So now, what am I doing today? So in the last video, I had a problem with audio. I couldn't hear what I was. At one point I stopped recording the sound. It was dumb of me, but yeah, whatever. And just basically what I did was I switched from this isn't necessary. Yeah. So I switched from um, classic pointers. As you can see here, these are remnants of the old pointers, but um, I switched them for for smart pointers. Shared pointers is one of them. I'm still learning how to use them because there's one special pointer that's called the weak pointer, which means that, I'm sorry, that the instead of allocating a lot of memory for a shared pointer, if you're just using it for a while and doing some calls, you can use a weak pointer, which just points, which is just increments some a variable, and then points to the pointer you in memory that you're worried about, and you can kind of use it to pass it around. If you need it, you use it for a while, then you stop using it, and it's lighter on your CPU. But the big thing is that from what I've seen in my code, I really need shared pointers a lot. So this perceive, as you can see here, if you're familiar with agents, with the agent architecture, this is kind of like it. So there's a concept of cycles between the the world updating itself and updating the agents. That means that the agent itself will be updated step by step. In this case, this is created so that if you, for example, if you update one agent and say it, I think I'll show you. It's better to show you. So this is the update cycle, and you can say, oh my God, this is awful, because it's a lot of cycles that you're creating, but this has a meaning behind it. And the main reason is that the perceive method gathers some events, and let's just say for each agent you'll perceive, you'll react, you'll decide, and you'll perform. And the perform action returns a list of events that this agent wants to share. For example, he's starting a new action, he's doing something in his action because these events relate to some emotional reply, some events of other kinds, but mainly on emotional and action events. And what would happen is, it's, for example, if one agent acts before the other, the first one would perceive the events that are taking place, would react to them, decide upon them, and then when he performs, he would put events back in the world manager that would pass to the next agent. This is a problem because the agents in each cycle don't receive all the events all in the same way, meaning that, for example, the second agent would perceive events, for example, from the previous cycle and from the agent that acted before him. And this would create different kinds of actions, and the decisions would be different. And this way, we guarantee that, okay, you all perceive in the same way, and you all act upon the same basis of events. This is not a very good implementation. It's a good implementation, but you can say, oh, but you could just put a thread here and let them all perceive at once, and then remove this cycle and have the agent react, decide, and then perform. Yes, we could have that, um, and that could also be put in a Python thread where we could lock, but that is not the real purpose of this project. So the real project, uh, I think I can show you. So this is my work. I don't think I should show you this, but yet again, no, sorry. If you want to see my curricula, yeah, never mind. So works, dissertation, and I think, yeah. So this is it. Oh, another very good program for PDF reading is it's Fox Read It for either Windows or Linux. I think for Linux is one of the best PDF readers that are around. So this is my whoa it died. So this is my proposition for a thesis, so to speak. Sorry, and what this means is that I'm going to try to increase the believability in synthetic characters. So in a scene for, let's say, 4 characters, and they are all interacting with each other, either fighting or talking or whatever it is. There's a lot of expectancy and a lot of emotions flying about. In this thesis, I'm not considering speaking, so that the information is passed through speaking, but I'll just say, okay, the characters are like actors and they know what the other actors will do, and this allows me to plan my stage in a way that, okay, all the characters, all the agents in this scene know more or less what's going to happen. So, for example, I could say, I'm going to walk to the door, and in reality, what happens if you're with a friend, you just say, okay, you're putting a foot in front of you, and I assume you're walking somewhere. I don't know where, but for example, if you're in a theater and you see, and you're one of the actors, and you have a guide where, okay, when he puts his feet, his leg in front of him, he's going to go to the door. Or the thing is, we're not trying to emulate the human interactions. We're trying to emulate a theater where we can improvise. Okay, let's get back to work. Let's get down to business. Okay, what I'm trying to do today is implement a mental state at Blackboard. Each character, each agent will have a Blackboard of his own, and it could be shared. I don't know. It could be shared, but we're still thinking that, okay, although these are actors and not really agents that's trying to emulate humans, let's just say that, hey, they have an attention span, meaning that, okay, for example, if you see if you hear someone scream, you can assume that they are hurt. But let's say that you seen them before that day and they were completely fine, and you didn't hear them scream, although they did scream, and then you're going up to them and say, oh, how are you? Are you okay? How are you feeling? And there you will have a small contradiction in you, because you saw them earlier and they were fine and they were happy, and now you see them again and their state is a lot different than before, but you didn't see that. Although if, for example, you were near enough to hear them scream and go run and help them, you would assume that they were hurt, were that they have changed their mental state. So you would change your your expectation for what they're feeling based on what you you paid attention to. So later, maybe I'll even um, implement or implement or change the perceive method, or even let the world manager decide which characters are paying attention or which characters don't pay attention to certain events. Because for now, any event that happens in the program, um, every agent can hear about it, and it's their choice to pay attention to them or not. Okay, so what's going to change? The thing is, this agent, it's an I agent. An I agent is basically a abstract class, an interface. For those who already know the nomenclature, the naming, sorry, nomenclatura, it's the Portuguese name. Uh, and as you can see, all these actions are pure virtual. Yeah, you have a name, but it's basically this. We haven't. I put the name here so to simplify the other agents, because from the start I started to implement. Oh, sorry, not this one. Let me close this. Okay, agents. Oh, yeah, here we go. I started to implement the agent class, but I started when I had the meetings with my professor. I started noticing. Okay, um, I've implemented um, some of these virtual functions that are needed to make the agent go. But I had a problem here, and the big problem was that, okay, I have a perceive method, and I have a perform method that are not virtual, because I decided so, and they implement some parts of the program that later I wish to change. For example, perceive. The perceive method, it's quite simple. The intent is that the event, sorry, the objective of the perceive is that I receive some events, but this simulates a human. So our brains have some delay perceiving certain actions. So when you're watching, for example, a basketball game, you see the player throwing the ball. It enters the loop, but your brain only detects that it entered the loop. So the brain only becomes conscious of the ball entering the loop after a very small time after the event really happened. Let's just say it's like having lag on the internet, but in our brains, and this tries to perceive it. But let's say I want an agent that doesn't do this. I want an agent that does something similar, but yeah, it changes here and there, and where would I put it? Yeah, I can't have this. So I thought of different ways, and the way I thought best was to let the world manager just have a abstract class, and later we'll just implement things upon it. Another thing is, I could, and I think maybe later I will change the way an agent is constructed because of this reason. The And what I mean of this reason is that the perceived method can or will be changed later. So imagine, if you will, that I have a decorator that implements perceive, and it implements perceive in this way. And later I'll just say, okay, and another decorator that implements React, another decorator that implements Decide, and so on, so on. Basically, it's just more performed and nothing more. But let's just say that we'll keep it like this, and I'll just say, okay, I want a new agent, and I want to decorate it with this timed perceive, this empty react, this empty decide, this empty perform, and yeah, that will be it. So I think I could do that. I don't know the real limitations. I still don't know lots of things, but yeah, I think I could do it, but not yet, if you know what I mean. Okay, let me just pause it for a minute. And whoa, this is funny. I'll just take a small break and I'll be right back. Okay, I'm back. I think I'll disable this for now. And yeah, so no visitors. Fantastic. Um, as I was saying, I think maybe later I'll try to eliminate the. I'll try to change things up a bit because I'm still like really learning how to do this whole um, hangout thing, streaming to YouTube, and for from the most part, I think I'll just start using maybe another software, but only if this becomes a thing, at least for me, because mainly this is my YouTube channel, and I just want to share things with you guys, anyone who's watching, and yeah, okay. If you have suggestions, you can just comment wherever you are. Um, if you're in Google Hangouts and you want to ask me a question while I'm streaming, or if you're on YouTube and you're later watching this video, this boring video, yeah, just ask. So, okay, let's finally do this because I was promised, oh, we'll implement things and stuff like that, and until now, we're not implementing anything. So, okay, let's talk about mental state. Okay, so as I said before, we will be implementing a blackboard. So the blackboard basically contains some type of some type of state of the world that this agent has built. And for now, we'll just say, okay, the agent is aware of everything. And personally, I think, okay, I'll create a mental state, a blackboard, but not like, for example, Unreal Engine blackboard, where it's generic. The blackboard can have everything and anything, and it's quite amazing. But I think I want something more specific, meaning that what I'll do is I'll try to have very little um, very little information, but very efficient. So I'll try it and we'll see. Okay, so I'm thinking, should I or should I not create a class within or a struct within the class itself? And from what I'm thinking, oh, and this emotional reply will basically disappear later. It's not really related, but I created it so that there was an abstraction between later implementations of, or if other people tried or wish to implement their own versions of an agent. And yeah, I don't know. So what I think I'll do for now is I'll create a mental state, yeah, I can call it mental state. And so what I think I'll do for now, let me open another app and I'll show you. Okay. Okay. Stop and share. So this I gathered some great tools for development. So let me just say, so, okay, okay, nice. I'll have, so here I have the agent. I can just insert. Okay, here it is. I can have description. I think it's this. Stereotype, constraints, attributes, methods. So I can write here, and the methods just show up right here. I can write the attributes. I can write constraints. Yeah. Okay. So I don't want any of this. I just want the simplest thing to show you. So here we'll have an attribute that will be the mental state. And next to it, and this mental state will mean to be a mental state, a class. Can align it. This tool is wonderful. And in this mental state, we'll have some other constraints. No, yeah, attributes. So we'll have a self state, a self. I don't want to call it a mental state because the mental state is of the agent, and it is composed of something that I don't know the name, but it's what does it what is it? So it basically it will be the representation. So yeah, it can be the mental. It will be the self rep, for example, and it will be a yeah. And a let's just say the others yeah rep. Let's just do it like this and open this up. Okay, yeah, okay, so now we'll even have a mental representation. And what the hell does this mean, right? Okay, so in simple terms, the mental representation of a class, of something, will be the expectations, the mental expectations. I'm not really good at anything. It's mainly at explaining stuff. So what I want to say is that an agent has a mental state. That mental state has a mental representation of himself. So what does he think he's doing? It's the basic idea to say, okay, what are you doing now? But not only that, is more like, where is your little where is your middle finger of your feet? This is an awkward question, but you don't really think about that much, because yeah, it's a finger that's on my feet. Yeah, what is my interest in that? So the great interest is that it is your mental state. You know, if you think about it, you know where your feet is and your fingers. And if you're like drugged, if you're with a hangover, or if you're drunk, you don't really know where you are, where are your feet even. But yeah, for example, where you are, if you're lost, then your mental representation of yourself and your position it's kind of lost. Yes, you know some uh, many things about you, but about your position, yeah, you don't know. You get what I mean? And the others, yeah, it's basically the same thing. Um, you, for example, know where your mother is, or where your father is, where's your girlfriend, where's your boyfriend, but you don't really know some exact things unless they're like next to you, talking about position, of course. So this will be kind of simple, meaning that the information we'll be storing here will be, so what is their current action, what is the current action state. So yeah, let me just write it. Yeah, the action, the state of the action, and their emotional reply. What are they feeling? So their emotions. Additionally, we'll have, yeah, but this is more of an implementation kind of thing that okay, it recently or needs update. I don't like this name, so let's just say date and say this is a boolean. Yeah, okay. So I'm not really classifying these because it's kind of not the point right now. And even the update, it's not really necessary right now. So the connections, the main connections here are, so an agent contains or has a mental state. Give me just a second. Okay. So we'll have a the agent and its mental state, and so one for one. This is the horrible part um, of this graphics designer is the text itself, because it doesn't allow for text in each of the, the source and the target. So we'll have to do something like, okay, it's one for one, and we'll just pick this up, lift it like here, edit it, and like bam, and yeah, okay, it does what it's, so the what we get is something similar to what we wanted, but it's not really good. So okay, now, oops, sorry. So now for the mental representation, in one part we can have, so a mental state. It's for each mental state, for each mental representation, there is only one mental state that holds it, and we can have one or more. I don't really remember the nomenclature, the naming, sorry, of these, or how to say It was not the plus, it was like the dot dot. Never mind. Let's just keep it like this. So what do we have? We have an agent with a mental state, and inside the mental state we have mental representations for himself and for other agents. So let's just do it. Okay, so now that we've talked about it, let's get our hand dirty and just do it. Let's create a new class. Let's say it is a... one thing, if I really wanted performance, I could just delete this. I could just say, I don't want this for nothing. I'll just, okay, I'll delete this and say that an agent has a variable called mental state, and the mental state is a vector of mental representations. Does this make sense? And for example, the first one was himself, and the other ones were like nothing at all. Okay, but I think I'd rather I'd rather implement them like I really wanted. So I'm sorry, I got a little bit lost. So although I have a mental state that harbors the mental representations, I could not have it for performance sake, but I rather have it for at least for organization, and it's not that heavy, although it will have a vector. Oh, it could have a map. Yeah, it could have a map. And then sort of by name, agents already implemented, I think. Let me just check one thing. So no, agents don't, but I could put it. So yeah, so never mind. I'll just create a class and just say, okay, this will be my mental. I think I'll start from the other one, so it will have a mental representation. Okay. And this mental representation will have a, as I said, it will have let me think of a thing. So it will have an action. Let's just call it. I don't know if I want to include the action. Do I need it? This is more a holder than anything else. This could even be a struct, so I really don't know. That creates a copy, implying that, yeah, we can have a class. We'll have a class. No, yeah, I think it's better to have a struct. So, struct. And let's just class. Let's say we'll have, here I need using and oh, sorry, memory. And here we'll say, okay, we'll have a cd shared pointer to a class of action. This is forward declaration. And this will be the action the agent is doing right now. Um, so SCD share pointer again, and this will be a class. No, sorry, this isn't even. mm, Okay. So the thing is, the shared pointer will always point to the action, and the action already knows the point, the current state. This is kind of a cheat, but oh, does it? No, it doesn't. The action, the agent. No, it does. It does because an action is composed of. Um, so I think yeah. Let me just check it. Mm-mm. So as you can see here, there's a stage type, and the current stage is going to be represented by this variable. And while an action is in progress, it will be either on anticipation, it will be on execution, follow through, or even cancelled. I think I'll add another one. I have, what do I have on my list to do? Implement agent. Okay, yeah. So later I'll add even another state, and more importantly, I'll just use this for now. So the each agent, current state, because this is a new stage. In fact, uh, this would be almost as copying stuff. Guys, I have to connect the mic for now. So, but you can still see me work. Any questions? I think now or later I'll answer them. Okay. Bye. Tentado mostrar a minha cara durante bem da tempo, suponho. Esta parte eu devia cortar completamente. Translating what I said was, have I been showing my face all this time instead of the code? And I should probably delete this part because although I haven't done much, I am now updating. What I did was, yeah, I created a mental state. I created the others, and the others will represent a class. Will be a map where I facilitate. I create. I make easier the update of the mental representation by storing a shared pointer to an agent. This way, when I want to update something like I'm about to do now, I'll just, let me just Google it. I'll just see if the key already exists, and if it does, it will, what will it do? Yeah, it will update the mental representation there and not create a new one. So this is the thing that I'll use. Okay. Let me just check C++.